number 3 says find the missing side of the right triangle. Again, since it's a right triangle, we can use the Pythagorean theorem. A squared plus b squared equals c squared, where x and 22 are the legs, or a and b, so we will put x squared plus 22 squared equals, oh, excuse me, that again, sorry, 10 and x are the legs, which are a and b, and 22 is the hypotenuse, which is c. Sorry about that. So we will put 10 squared there equals 22 squared. X squared plus 100 equals 484. We're going to subtract 100 from both sides in order to isolate the variable. You're left with x squared equals 384. And now we have to isolate the x squared. We are not solving for x squared, we're solving for x. So we take the square root of both sides. Square root of x squared equals x. Square root of 384. Now, there's a number of ways of doing it. You can do it pretty basic. You can see that 64 goes into 384 6 times. And the reason why, we're looking for perfect squares that are divisible into 384. So we're looking for numbers starting with 4, 9, 16, 25, 36, 49, etc., 64. And we're looking to see if any of these numbers are divisible into 384. And we see that 64 goes into 384 6 times. Square root of 64 is 8. And rad 6 is simplified completely. So the missing leg is 8 rad 6. Let's go to page 3. Page 3 gives you special right triangles. The following right triangles are 45, 45, 90, which is one of the two special right triangles. And we know that in a 45, 45, 90 right triangle, that the legs, and I won't use X, so I made that mistake earlier. The legs, which we'll notate as A, has a relationship to its hypotenuse, which would be A, the leg, times rad 2. So, if we know that A equals 4, we know that X will also equal 4, and we know that Y is going to equal A rad 2, or in this case, 4 rad 2. Pretty simple. And again, come over here, draw a right triangle, 45, 45. We have A rad 2. And this time they give us the hypotenuse. And they show us that A rad 2 equals 5 rad 2. You can do this mathematically, and you can say that 5 rad 2 equals A rad 2, and in order to isolate the variable A, we get rid of what's happening to it, being multiplied by rad 2, so we multiply by its reciprocal, which is 1 over rad 2. Notice the rad 2 in the denominator cancels with the rad 2 in the numerator, and we're left with 5 equals A. So, since our legs are identical, X equals 5 and Y equals 5. One thing that I want to really fix is the pen is off so bad. And I don't know if it's because of Keystone or what it is. It's so difficult to write nowadays.
Did you do the stuff?
Yeah, I did. Yeah. Page 4. Page 4 deals with the second special right triangle, which is 30, 60, 90. And we have values again. You have the short leg equals A. The hypotenuse is going to be twice the short leg. And the long leg of the right angle will be A rad 3. So we're given the long leg in this first problem. So as we did in problem number 4, we would isolate the variable. We could set it up as an equation. 10 rad 3 equals a rad 3. And to isolate it, we multiply by 1 over rad 3, 1 over rad 3, 10 rad 3 over rad 3. They cancel. And you're left with a equals 10. Remembering that a is the short leg. So since the short leg and x equals 10, and the hypotenuse, which is y in this case, is going to be twice the short leg, or 20. 2 times a, and we get that. So very simple. In problem B, this time they give you the hypotenuse, which is 12, and we know that the hypotenuse in the 30, 60, 90 is going to be 2a. So if we set up the equation again, 12 equals 2a, multiply by 1 over 2 in order to isolate the variable, you get a, or the short leg, equals 6. So y equals 6, and that means the long leg is the short leg, 6 times rad 3. So x equals 6 rad 3, y equals 6. Page 5 starts working on a lot of the work that we did in sections 10.7 and 10.8 using sine, tangent, cosine. And as I've stated in the past, sine equals the opposite times the hypotenuse. Cosine equals adjacent over hypotenuse, and tangent equals the opposite over the adjacent. So in this case, we're looking for the sine of A. We have to keep in consideration the angle here and the perspective. When we talk about the sine, the opposite is going to be 20, and the hypotenuse, which will stay the same, is 25. So the sine of angle A equals the opposite 20 over 25, which reduces to 4/5. Tangent of A, tangent of angle A equals the opposite, which is still 20, but this time we have the adjacent, which is 15, and that reduces to 4/3. Cosine of B, we have to erase a lot of this because I'll erase this. Put that solution back up there. But this time when we look at the perspective of B, we have to change our opposite. And we're looking for the cosine, which is the adjacent, which is 20, over the hypotenuse. Okay, so the adjacent is different here. So cosine of angle B equals the adjacent, which is 20, over the hypotenuse, which is 25, which reduces to 4/5.